So in this clip, we're going to compute the total charge on a ceramic chip, where the charge density on a piece of this chip, on this piece, is bounded by this parabolic cylinder, x equals y squared, the plane x equals z, and the planes z equals 0 and x equals 1. And the charge density on this chip is going to be given by x times z. All right, so we'll go ahead and figure out what our region is. Like I say, it's always good to become friends with your region. So if we look at x equals y squared, this one is going to look like, let's see, it's going to be opening up in the positive x direction. So it's going to be some kind of cylinder that looks like this. So add a couple more of those just for grins. Okay, and okay, so we can see what that looks like. And then what do we have for the other ones? Well, x equals 1 is going to be this plane kind of, so if we come out to 1 on the x-axis, there's going to be some vertical plane here that's chopping it this way, and then x equals z, so that's x equals 1, x equals z, that's going to be some plane containing the y-axis. And so it's going to contain the y-axis, and it's going to come sort of up and out and forward through the y-axis towards us, and that's terrible. Okay, so at this point I can kind of see that I'm looking at this from completely the wrong angle to visualize it correctly. So I'm gonna have to spin things around. So let's see. So now if I imagine I'm in this picture over here, looking at it from the side, so from the negative y-axis kind of end on, then I would see this kind of picture here. The x-axis would be coming out forward, and z would be going straight up. And this plane that I'm interested in drawing is going to be doing this angle right here. This is where x is equal to z, or z is equal to x, whichever you prefer. So I'm going to draw it kind of like that. So let's rotate it with, so we've got, I guess, x going this way, and y going this way. Yeah, this should be palatable. There we go. Okay, so then I've got my, if I go out to, oh, actually, I'm sorry. No, I don't want to do it like that. I want to do it where this is x and this is positive y. And we still have good old z going straight up. There we are. Okay, so now I'm going to draw out here somewhere. This is going to be x equals 1, which is one of our curves, and we've got, there's our parabola, so that's x equals y squared, and then I've got a plane coming up diagonally, sort of splitting the difference between the two, because x is equal to z, so that's there, and it's also here and here and there. Okay. And oh, you know what? If I were really smart, I would have extended this to be kind of like up above the axis over here. So this is like, or not the axis, the x equals 1 line. There we go. Okay. And so now I come down, so I'm drawing in the rest of, actually here, let me color code this. So this is the x equals 1 plane. And then I just have to include the top surface where the cylinder got chopped. So it would be like some parabola going like that. Hey, All right, pretty snazzy. Okay, so I'm going to switch to fat pen here and just do an outline in orange so it comes down like this and down and out and across the top, and then somewhere in the background there's this thinner part there. Okay, so hopefully you can now see that that shape. There we go. Okay, so that's the kind of shape that we're looking at. And so we can imagine, what would this look like if we projected it in different directions, right? So I'm starting to think about how would I take this object and set it up for integration in one direction, like with one variable first or another. So let's take away all those bits and pieces there. Okay. So if I were to do an x integration first, then everything would be more or less projected onto this vertical wall right here, and it would look like, let me just do a doodle here of what it would look like after we've done the first integration. Okay, so a line that's coming in like right through here and leaving through that point, that's going to hit somewhere on the slanted plane and then leave through the backside, as opposed to if I have something that's coming in over here and leaving through a point like this, that one's going to hit somewhere on the front of this parabolic cylinder, right? So that means that the shadow is going to be cast something kind of like this, and we'd have to break that into a couple of different elementary regions depending on the start and stop surfaces for that particular direction. Okay, so that one is not looking particularly appealing. The next thing we could do is we could talk about integrating in the dy direction first. And if we did that, then we would see something that looks like this one right here, and maybe move it a little bit to get it away from that other junk. So this is the z-axis and the x-axis left after doing a y integration. Just like after doing the x integration, we'd be left with the other two variables, y and z. And so at least we just have a little triangle, but we're going to be going from, for lines piercing through this direction here, we're going to be starting on one side of one branch of a square root and ending on the other branch of a square, going from negative root to positive root. And who likes dealing with square root functions, right? They're not the most fun thing to integrate. So the last thing to do then is to consider what happens if we do a vertical projection. So if we do dz, and since I don't have room up above, I'm going to draw it down below. And so in this case, we would have, let's see, so there's our parabola, sort of parabolic shadow of this guy. And once again, what's going on is we integrate dz, so we get the other two variables left. So this is going to be looking at the xy plane. And so that's not a bad region to set up. And in any one of our dz-oriented lines, so when we pierce through like this, we're going to be hitting on the bottom floor, which is the flat plane z equals 0, and then leaving through the slanted plane up above, which is the z equals x plane. That all looks quite palatable. So once again, I'm going to set up with dz first. Now, I don't know why I chose another example where we do the dz one first. It doesn't really matter which way you do it, as long as you set up the integral in a way that can be integrated. So going from this last one, let's see. So we're going to be starting then on this surface down here is going to be where we enter the object. We are doing vertical dz integration first, and then we're going to be leaving, wrong pen. We're going to be leaving through this upper surface here. Okay, so we go from, let's see, so the bottom plane is z equals 0, and the upper plane is z equals x. We don't even have to solve those. And then we're going to be integrating a density function this time, xz, and that's going to be going dz because that's what we decided to do. Now, we need to do the x and y integrals, and so we have to figure out how to set this one up. And like I said before, doing dy next is going to be bad because we're going to have to go between square roots. We'd probably be better off going this direction next. So we'll do dx. So let's see. So then we're going to go from, let's see, x equals parabola up to stopping on x equals 1. So we go, let's see, so x equals parabola, that's x equals y squared, and we go up to x equals 1. And then the last one is where are those slices, and you can tell by looking at it, it's y equals minus 1 to y equals 1. All right, and so there we go. So that's going to be the total charge on this object, and just for grins we can actually go ahead and compute this one. So this is from minus 1 to 1, y squared to 1, and then if I integrate that with respect to z, the x part is just going to be hanging out, and I'm going to get z integrates to z squared over 2, and I go from 0 to x, so this becomes x squared over 2 dx dy. And then, so we've got a factor of 1/2, and x cubed integrates to x to the 4th over 4 from y squared to 1. And so we've got 1/8 of the integral from minus 1 to 1, and then I've got 1 minus y to the 8th, and integrating this guy gives me 2/9, and there's your answer.